Now it's time to go with the next presentation. Another very long time active developer, like Anders, more or less, Henning, showing a couple of tips and tricks and more information about the variables and transformation. Henning, everyone, I guess, knows you from the community, but I'm sure you want to present a little bit about yourself and what you do these days. The floor is yours. Thank you for joining us.
Thank you, Daniel. So let me share 1 second. Okay, perfect. Yeah, 20 years, crazy. Thank you again, Daniel, for the chance to participate in this event. It's great to be here, at least online, and hopefully we meet soon in Berlin. So for the agenda, as said, I want to talk a bit about some foundational stuff, about transformation, pseudo-variables, how to use it, and how they came, how they were developed, and this kind of things, what you can do with that. Quick background about myself. I started Kamailio using Kamailio in 2007, and since a few years, I started a company, dialog, and we offer all kinds of services related to real-time communication. We do, our customers are mainly service providers, and we work with different customers in Europe, but also international. Quick recap or overview. Most of you probably know about the structure, but nevertheless, it's probably good to do a quick recap about Kamailio, how the server looks like. So we have a core, something that we call core, which does all the heavy lifting, like parsing of configuration files, parsing of zip messages, of course. Its interface transport layers like UDP, TCP, TLS, and other, provides locking, memory management, and all kinds of different things. And as frequently mentioned, and you also mentioned it a few minutes ago, we have a lot of modules, over 200, and these modules interact with the core, and are in this graphic are grouped together or below the core and interact about a module interface with the core. So far for the rough overview. Kamailio, as you know, of course, works as a configuration language. It executes the configuration for each request or reply, depending on different situations, does different things with these zip messages, and of course you interact in the configuration with these zip messages over different means by calling into modules, using core functions, or using pseudo-variables and transformations to access different message content, modify message content, and different things. The configuration by itself, another recap, just for completeness. Of course, you have the different configuration variables. You have your modules that you load in modules, core statements where you modify the core behavior, and then different routes, main request route, and of course additional routes which can be used to modify the execution of Kamailio and the logic that it's implement for the zip messages. The pseudo-variables or PVs, as we shorten them, and transformations are of course mainly used in the configuration routes, in the request route, and additional routes. In some modules, you also can specify them, but this is some kind of bit of like different functionality, different use cases. If a request is processed from Kamailio, it is basically, it ends up in the Linux kernel, of course, on the network stack. Then it's sent to to the transport layer components of Kamailio, for example, over UDP. And then, as I said earlier, the main request route logic is executed in the Kamailio, and then you have different ways of interact with this message. You can, of course, just send a reply. It's allowed, it's forbidden, something like that. You can drop a message, you can forward it to another destination. A classical use case, for example, for an SBC is just presented in the previous presentation. And then there are different routes that you can engage basically in these request processing for later execution. The second part of zip message processing, you know that zip is like a request response protocol. Basically, you send an invite somewhere, and gets, for example, 407, please authenticate yourself back. And request and replies. And replies, of course, are also executed and processed in Kamailio. They're not executed, as you for sure know, they are not executed via these main request routes. They are executed in the on-reply routes. And then you have different options for like failure routing, on-reply routes, where you can, which you can use to implement different logic. NAT traversal, for example, as we just saw some minutes ago. Media handling for RTP and different things. Pseudo-variables were created basically to generalize and standardize the existing special variables that we had in Kamailio, or before that in OpenSea. Before that, we had some variables, or in fact, they're still there. They're still also used in the default configuration. We have something, for example, it's called URI to access the request URI, or source IP to access the source IP, basically. And there are other variables for that. But over time, of course, it didn't scale to just invent new keywords. In the end, these keywords needs to be unique in the configuration language. So the design with these PVs were basically a way forward to extend the configuration language, the script language of Kamailio. The first PVs were introduced in OpenSea times 2005, at least to my research. Daniel can probably mention a bit more later about that. And then over the years, of course, were extended substantially. First were the PVs that were part of the core, and in 1.5 they were moved to the PV module, just to modelize the core to make it smaller, more lean. Over time, as I said, there were more and more PVs added to Kamailio, and then again there were some redundancies introduced. For example, if you want to access a 2-header, you want to probably get the full 2-header, you want to get the user part, you want to get the domain part, you want to get the port, maybe the parameters, etc., etc. And it would be, again, pretty tedious and also a bit of overkill to add now like basically hundreds or thousands of different PVs just to access these different parts of a message. So a second thing we added basically to the scripting language, another keyword, or another like logic, not a keyword, a logic, sorry, the so-called transformation. They were added to provide a modular or extensible way to access certain information from PVs and or to format them in a certain way. They were added a bit later for OpenSea 1.2 in 2007. And in 1.5 in 2009, there was the first major module introduced that also used PVs as its main interface to work with it. So this is a bit like the evolution of this whole functionality, how it was developed in the time. What is a PV? What is a pseudo-variable basically? It's used for special tokens that can be given as parameters to different script functions. And if the script is executed in a certain route, then they will be replaced with a value before the execution of this function. The beginning of the PV is always marked with the $sign, of course you know that. And as I said earlier, most of them are implemented by the PV module, but also many other modules provide access to some functionality over PVs. They should be supported by most core and module script functions. They should. It's like there are some parts maybe that still not fully support them, but I think in the last years, all the developers did a great job to get rid of all, or like to improve the functionality, or maybe get rid of old functionality to have it properly supported all over the place. You find the documentation for all of them, of course, in the wiki, in the cookbook section. And of course, being a real-time server, Kamailio users care a lot about performance. Just a quick note here, as most of them are used in memory or offer in-memory operations, the performance of PVs is quite good. They are quite fast, so you should not notice any delay, etc., by using them, even if you have large and complicated constructs. Just to present a small snippet from the default configuration. You all are aware of that, of course. Here we have some example usage. We have a $AVP, an AVP variable. Yes, we check for value here. We have some other variable $RU, the request URI. We assign a value here with some string concatenation to another variable. So you can use them pretty natively in the configuration language, and use them in whatever logic you implement in your config. What kind of PVs are available? Just to give you a broad overview. Some of them, or many of them, are probably known, but nevertheless, just a quick overview, also to describe a bit the difference between the different PVs and what are the specialties and what are they used for, etc. Of course, we have something like flags. There's a PV for that, $MF. We have, as mentioned before, the classic variables, UI, source IP, etc. They are not PVs, just normal variables. And then we have a lot of, basically, I think the most PVs are related or dedicated to providing access to zip message content. $RU, for example, to get the request UI, $F capital U to get the form header username, $header with some variables to with a key, to access arbitrary headers and so on. As I said, there are a lot of them, and basically for most well-known headers are PVs available. If you want to access zip reply content, there are also special PVs available, $RR, for example, to get the reply reason phrase and things like that. The PVs on the previous page are just, giving access to certain data, basically. Now, just to explain a bit more complex concepts, we have a class of transactional PVs. Transactional, as you know, most Kamailio installations work with transaction. They use the TM module, transaction monitor module, to implement, for example, proxy functionality in a stateful way. And if you handle a transaction, if you handle messages in the transaction, you probably want to also have some access to transactional context to see, okay, I get a reply, and the reply, I can match some data to some invite request, for example, earlier. And for that, we have the AVPs, attribute value pair. This is the long name for that, the transactional variable, and they do what I just described. They belong to zip transaction, and you can access them and modify them as long as the zip transaction basically lives. Over the years, there have been some extensions in this regards. We have $XAVP, extended AVPs. They support an index or field access. So you can have something like I described here, like a person with the first name, and a person with a last name with different values, and then you can access basically these different values in a with this index or with this field access. All these AVPs can be indexed, so you can have an index parameter like square brackets 0, 1, 2, 3, etc. Just to for completeness sake. Then there's XAV. It's similar to XAVP, but it's case insensitive for keys. Sorry. Really helpful. For example, if you process zip messages where you have case insensitive information. And there's XAVU, similar to XAVP, but they have unique values. They are unique for values, sorry, and have no indexes. If you don't want to be tied to the zip transactions, you need to have a bit more, you need to have a different semantic in the configuration. There are other PVs which works in memory. You have something like $SHD, as I mentioned, the hash table module, basically in memory, hash table implemented to store data forever in memory or with a certain expiration time. Then there are some variables that are shared between processes, like in shared memory, and you have also $var, for example, the variables that are individual per process with different flavors, with default 0, default $null. So it's different, a bit of different logic behind that. If your proxy is dialog stateful, you can also use PVs related to this dialog module. For example, you can use something like $DLG_var to store and retrieve customer variables for the processed dialogs. For example, you have a call and you want to store like a carrier that you have used or that you want to use, or maybe a certain gateway that you want to use in this call, maybe other attributes related to billing or maybe quality. So this can be really handy to basically store information that belongs to the dialog. There are different PVs related to time handling to get like a current timestamp or different current time. And you have also PVs that give you access to the environment. And this is especially handy, for example, if you want to use something like Docker or Kubernetes, and a lot of variables needs to be dynamically set. Sorry, and with this $env $environment, you can access the Linux environment and, for example, get a server port or server name or stuff like this. This can be really handy. You all are aware of this Kamailio definition. Define, like sharp define, preprocessor support. There are certain PVs also to work with that. There are different modules, for example, TM or UIC that export PVs to work with transactions or to create zip requests and all kind of different stuff. So pretty powerful. I already mentioned a few use cases, and in the previous talks, we also got a lot of ideas, a lot of use cases. For example, you can, with $UA, you can evaluate the user agent string and block certain devices. This is already done in the default config. You can use a hash table, for example, to improve the performance of your database. If you have a multi-homed setup for an SBC scenario, for example, you can use the $fs for send socket PV to force a send socket for outgoing packets and messages. And as I mentioned, you can, of course, use PVs to access data from many different sources, like SQL ops for SQL databases, Redis for Redis databases, and all kind of different things. So far about the PVs. Now a bit to the transformations. What is a transformation? As mentioned before, transformation is basically a function that is applied to a pseudo-variable PV to get a property of it. They don't affect the value of the PV. They are read-only operations. And the goal is to provide a modular system, as I said, to prevent the addition of hundreds of special PVs, basically. transformations are implemented by various modules, most of them being the PV module. And yeah, they use like a special marker, these curly braces as seen below, and they follow the PV name. And if you're using transformations with PV that has also some parameters, it's the syntax is a bit more complex. I think I have an example later on as well. Of course, there are other ways of evaluating variables. There's like a module called ziputils, which was provided to also access a lot of these data from messages and stuff like this. From SER times, we inherited the select framework, which is a bit different way of accessing data. There's a bridge in these PV world also with the $SEL to access selects. But nowadays, or like at least since several years, most of the work is done in the PV and transformation area, and selects are not extended anymore. Just to give a few examples about transformation usage. For example, imagine you have the from user and you want to get the lang, then you can use the curly braces in these brackets and just apply this transformation to the from user, and you will get the lang as an integer value back. You can also chain this transformation like multiple times, or like apply them multiple times, or different transformation to one PV multiple times. For example, here we have transformation, two transformations. We have a header, it's called x minus SBC, and we escape it, and then we want to get the length of these resulting escaped header, basically. String operations can be, transformations can be separated or like classified also according to their main usage. So one thing, or one important thing is of course string operations, length, conversion to integer, trimming with different directions, all kinds of string operations are provided from transformations. You find all the transformations, of course, in the cookbook. They're indexed there. You can do data conversions, like encoding to different character sets, encoding to base 64, this kind of stuff. Sometimes it's needed for certain message operations, or maybe for your own interfaces to some existing systems. You can do escaping, which is in particular important if you have an interface to an SQL database and you're using raw queries with SQL ops. There's something like escape common, or SQL.val, which you can use to properly and securely query your database. Then there are UV transformations to access all kinds of data from zip UI, like the user, the host part, the port part, etc. There are also special transformations for special use cases. For example, get this simple AOR part, address of record part of an UI. I just gave the example here at the bottom. But there are many more. There are parameter list transformations to access certain values from a concatenated string. For example, like A equals 1, B equals 2, C equals 3. And then you apply the transformation here, and you want to get the value from C. Of course, it's 3. There are name address transformation to access like UIs with a display name, what you have, for example, in a from or to header. And if you have more complex UIs, then normally the two-body transformation is pretty useful to access values for more complex headers, like, for example, a to header or from header. In the previous presentation, we had these some net scenarios, and for that, these UI alias transformation can be really handy to encode and decode certain parts of a network address, for example, and then later decode it when you get it back to have proper netting and these kind of scenarios. You can parse JSON. You can do hash transformations if you want, for example, do some security stuff. So many different options. Select operations can be handy, especially as you've seen before. There's these, if you have a parameter string, here you can use this transformation with a special separator and then get like the first, the second, the third part of a certain string. And at last, of course, there's also a regular expression transformation, which can be used to do all kinds of arbitrary transformations with regular expressions on the zip message. Okay, that was pretty fast, right to all kind of different transformations and PVs. And I'd like to thank you for the attentions and looking forward to your questions. Thank you.
Yes, thank you very much, Henning.
Thank you, Henning.
We haven't got a lot of questions, but I noticed that you only mentioned the read capability of the PVs, not the writing capability.
That's right.
That's pretty confusing for a lot of people.
Of course, it's not only reading, but of course also writing. It's for some PVs. I had it also in the examples. You can of course also write and modify parts of the zip message. It's too weird, of course. It was too obvious for me. I'm sorry. Sometimes you skip the important stuff.
It is, and another thing that's confusing quite often is that when you write to a variable and then read it again, it retains the old value.
Yes.
Could you try to explain that?
Sure. So basically this boils down to like a design choice which were done 20 years ago, more or less, you can say. So during that time, of course, servers were much less powerful. We had not like 32 cores or whatever really readily available and lots of RAM. So they did a certain they implemented a certain optimization. As I presented earlier, the zip message gets basically fed into Kamailio, and then it's passed. And this passed state is then basically processed in the scripting language. And if you do a operation, for example, reading a variable, this value is just returned to you in the scripting language. And if you do a modify, like a write operation, this value is not changed in this internal representation of the message, but it's put in some kind of record-keeping log called a LAMP system. It's the internal technical name. And this log basically is then added, okay, change the request over here and change maybe the another header there, etc., etc. And when the message gets sent out, these lumps are basically committed or applied to the message, and then, of course, can be seen on the other side at the receiving party. Yeah. There's a special function, this message apply changes function, which can be called to basically force or commit all these changes. But this should be only used if necessary because it can have some side effects. That's also documented there.
So basically, if I understand you right, you have an incoming buffer where you read from, and you manipulate an outgoing lump buffer. So if you continue reading after manipulating the outgoing buffer, you fetch the data from the incoming buffer.
Exactly. So you have the incoming buffer, which is like kept, and all your access goes to this incoming buffer, doing the whole complete config operations, and the writing operations will be stored in a separate place and only applied if you send out the message, right?
Yeah. I don't see any other questions, but I see a lot of hooray saying this is great onboarding material, great education, very, very well done. And I fully agree. Thank you, Henning. And with that, and a virtual applause, I give the word to Daniel.